Hey guys, today we are talking about solving compound inequalities. Now compound inequalities are just like regular inequalities except we have two less than or greater than signs. They're written in two ways. The first way is like this, where we have it all together with my x in the middle and we have our less than or greater than sign on the outsides. That is called a conjunction, and that is when it's written together. In a conjunction, your shading is always going to intersect and it's going to come together. So whenever you graph, you can always be thinking that it's going to be coming together. The other way is if I have a big or here. And with that or, that's what we call a disjunction. So a disjunction compound inequality is written separate. So my two inequalities are written separate with a big or in the middle. And my shading usually goes apart. So on our graph, it's going to go out to the left, out to the right. Sometimes, though, they go together. We'll talk about exactly what that means in a second. Let's take a look here at number 1. So you might be asking yourself, well, how can I solve this? Well, it works the same way as a regular inequality as an equation. What you do to one side, you do to the other. But in this scenario, there are three sides. We have this -5, we have this 2x plus 3, and we have this 15. Well, what I do to one side, I have to do to all sides. So for instance, if I'm trying to get this x right here by itself, my first step would be to subtract away that 3. But the thing is, if I subtract away the 3 in the middle, I need to subtract away the 3 to all three sides. So we would go -5 minus 3 is -8. And then 3 minus 3 is 0, so we're just going to have a 2x here in the middle. And then 15 minus 3 is 12. So it's as simple as that. What you do to one side, you do to all of your sides. And at that point, it's as easy as a regular inequality to solve. Next up, to get x by itself, what's my step going to be? Yeah, we need to divide by 2. So I'm going to divide the middle by 2 to get x by itself, but if I divide that by 2, I need to divide this side by 2 and divide this side by 2. So that does indeed just give me x by itself. However, -8 divided by 2 is -4, and 12 divided by 2 is 6. So that gives me my final answer. And this is written as a compound inequality. So here's my answer. I'm going to go ahead and box it. Now we're going to take some practice in graphing it, writing it in set notation, and writing it in intervals notation. So our first step to graphing it is I'm going to put my points. I'm going to put a point here, and I'm going to name it -4. I'm going to put a point here and name it 6. All right, at this point, am I going to have an open or a closed circle? Yeah, I'm going to have an open point at -4, and I'm going to have an open point at 6 because they are both just less than or greater than, and they don't have an equal to it. All right, so x, remember, it's always best to read from your x value. So x is greater than -4. Hey, that means we're going to go to the right. X is less than 6. Hey, we're going to go to the left. Hey, look, it intersects in the middle, so here's my graph. For set notation, remember set notation is just the fancy way to write my inequality. We go my squiggle bracket, x such that x is greater than -4 and x is less than 6. For interval notation, this is really easy because we already have my farthest left part of my interval and my farthest right part of my interval. My farthest left part of my interval is -4. The farthest right part of my interval is 6. Now, am I going to use parentheses or brackets on this interval notation? Yeah, I'm going to use parentheses. Because remember, we use parentheses whenever it's not equal to, and we use brackets whenever it is equal to. Okay, let's take a look here at number 2, at my first disjunction one, my first one with an or in there. So we're just going to solve each of these. I'm going to start off solving number 2 here. I'm going to minus 6 to both sides. And hey, look, there's my answer. X is less than negative 2. On the other side, I'm going to start off by minusing 7 to both sides. That's going to give me negative x is greater than negative 6. Now I need to get that negative away from that x. And to do that, I'm going to divide both sides by negative 1. Okay, so negative 6 divided by negative 1 is a positive 6. Now what happens when I divide both sides by a negative? We have to flip the inequality sign. So I'm going to need to take that inequality sign and flip it. So it's going to go from a less than to a greater than. Remember, when you multiply or divide both sides by a negative, flip the inequality. Okay? All right, so here are my two answers. We have an x is less than negative 2, or x is greater than 6. Now we can put both of these on my graph. I can put one here at negative 2. I can put one here at 6. And we're just going to circle both of these since they're not equal. And since it's less than negative 2, we're going to go to the left. Since it's greater than 6, we're going to go to the right. Okay, for interval notation, I'm going to write parentheses, negative infinity to negative 2, union. Remember, we use that u to do interval notation whenever we have 2. Okay, union, parentheses 6 to positive infinity. Y'all see how this matches up with my graph here, right? We go from negative infinity up to negative 2, parentheses because it's not equal, union, that's kind of the gap, parentheses because it's not equal, 6 to positive infinity. Okay? All right. Now let's see here. Set notation. For set notation, remember all we're doing is we're taking that and we're rewriting it, right? But we do it fancy. We do all numbers of x such that x is less than negative 2 or x is greater than 6. All right, let's go ahead and move on down here. Take a look at number 3. So number 3. We have another disjunction problem that we're going to need to solve. We have a greater than or equal to on this side. We have a greater than on this side. So let's go ahead. Let's distribute those negatives. Let's solve this out. So I'm going to go negative times x is negative x. Negative times negative 1 is a positive 1. To solve this, I'm going to subtract 1 to both sides. That's going to give me negative x is less than or equal to negative 5. Now to get rid of this negative, I'm going to divide both sides by negative 1. And remember, when you multiply or divide by negative, we flip the sign. So it's going to be a positive x is greater than or equal to 5. I'm going to do one more step here. I'm not just going to leave it as written on, I don't like x written on the right side. It's annoying to me. So I'm going to rewrite it with x on the left side, but it's still going to be the same thing. X is still going to be greater than or equal to 5. Just make sure whenever you flip these sides that you keep it meaning the same thing, that x is still bigger than 5. X is still bigger than 5, okay? All right, let's solve this other side. Let's distribute this negative. We're going to have negative x, and then plus 1 is greater than 4. I feel like we've done this before. That's minus 1 to both sides. We'll have negative x is greater than 3. Then we'll divide both sides by negative 1. And x is going to be less than negative 3. Remember to flip your inequality signs if you multiply or divide both sides by a negative number. All right, so here's my answer. I have x is greater than or equal to 5, or x is less than negative 3. So when I write this as if I graph this, I'm going to put a point at -3. I'm going to put a point at 5. I'm going to circle the point at -3, and I'm going to fill in the point at 5 because the one there is equal to. So they can be different. Okay, then it is less than -3, so we're going to go to the left here, and it is greater than 5, so we're going to go to the right here. For interval notation, I'm just going to write it out just like what we have on my graph, right? I'm going to go parentheses, -infinity, all the way up to -3, parentheses because it is not equal. I'm going to write my union symbol, another, oops, messed up. Instead of putting a parentheses there, I need to put a bracket because it is equal to 5. And then I'm going to go 5 to positive infinity. For set notation, remember set notation is just the same as your inequality. It is just fancy. We're just going to do all numbers such that x is less than -3 or x is greater than or equal to 5. It does not matter which order that you write these in, just make sure you get both of them in there. Alright, our last one on this first page, let's take a look here at number 4. So number 4, this is a conjunction one. It's in the middle. We have a fraction. We're just going to solve it out. And the first thing that I'm going to do is I'm going to clear out this fraction. How do you clear out a fraction? You multiply by the denominator. So I'm going to just multiply by the denominator to everything. You know what? Actually, let's just go ahead and get rid of this 7 first. We can do that first. Let's add 7 to all 3 sides. That's going to just leave me with 3/4 x is greater than or equal to 0, is less than or equal to 3. Now let's clear out that fraction, okay? Let's multiply this by 4, let's multiply this by 4, and let's multiply that by 4. 0 times 4 is still 0. 3/4 times 4, cancel out that bottom, it's going to be 3x. And then 3 times 4 is 12. Last step, we've got to get rid of that 3. Let's divide both sides, all 3 sides I should say, by 3. It's going to give me 0 is less than or equal to x is less than or equal to 4. Okay, let's put a point at 0. Let's put a point at 4. And we're going to fill in both of these points, right? And x is in the middle. This is a conjunction one, so it's going to be together. So for set notation, really straightforward. It's just going to be all real numbers, x such that x is greater than or equal to 0, and x is less than or equal to 4. Interval notation also just as easy. My leftmost interval is 0, my rightmost interval is 4, and are we going to use brackets or parentheses on this? We're going to use brackets because it is also equal. Okay? Alright guys, let's take a look at one last one. Let's turn to number 5 on the back here, and we have an OR problem. We have an x plus 3 is greater than 7, or 3x is greater than or equal to 18. Okay, so I'm just going to solve both of these, and the reason I'm showing you this one is because this is going to be one that's going to look a little bit different. These are actually going to go the same direction. It's not as hard as you think though. Let's go ahead and solve these. I'm going to minus 3 to both sides here. That gives me x is greater than 4. I'm going to divide by 3 to both sides here. That's going to give me x is greater than or equal to 6. I love it. Alright, so there are my 2 answers. I'm going to plot these out so we can see what these look like. Remember that we have an OR in the middle here. So here's my answer. I'm going to put a point at 4, and I'm also going to put a point at 6. I'm going to leave open the point at 4, and I'm going to close the point at 6. Okay, now x is greater than or equal to 6, so from here it's going to go to the right. And x is also greater than 4, so this one's also going to go to the right. And you'll notice that they intersect once they get over to this side. But this is an OR, so we can count any of it. We don't have to count where they intersect, we can count all of what's going on. So for set notation, for my answer, the only thing that I actually have to write is this. All I have to write is all numbers of x such that x is greater than 4. The reason I can only write this is because everything that's greater than 6 is also greater than 4. So just by writing that, I'm including everything on my graph. So it actually makes it simpler. And for interval notation, the only thing that I need to write is parentheses 4 to infinity. All right? Because infinity encompasses all of 6 to infinity as well. And so it actually makes it a little bit easier. All right, guys. Number 6 is going to be on the completed notes on Canvas, so make sure to check that out if you need some extra practice. And if you have any questions, let me know, and I will help you the best I can. Make sure you answer all the questions, especially this one. That one's going to be on your video as well. All right, guys. Y'all have a good rest of your day.